Hey there, and welcome to this explainer. Today we are diving into a seriously fascinating text by Shofeng. We're going to explore this massive, kind of mind-bending gap between the physics of the incredibly large and the physics of the incredibly small. And to help us cross this huge gap, we'll be looking at some wild, brilliant analogies used in the source text to bridge it all together. It's a journey that literally starts with the fabric of space itself and ends with a deeply philosophical critique. So, to set the stage for our central physics problem here, the author asks a wonderfully quirky opening question. How are quantum field theory and general relativity like a pair of pants? I know, it sounds exactly like the setup to a joke, right? But honestly, it's actually the perfect entry point into what is arguably the greatest crisis in modern science. This source text explains that modern physics is currently standing on two entirely separate legs. Over on the left side, we've got general relativity. That's one pant leg. And on the right side, we have quantum field theory, the other pant leg. Now, both of these theories are absolutely incredible at describing their own specific domains. The problem? They describe completely different things. They are entirely separated, totally incompatible, and right now, well, they just can't seem to walk together. To understand why they can't walk together, let's zoom out to the macro world. General relativity is Einstein's domain, right? It mainly deals with gravity. But here's the twist. Einstein held that gravity doesn't actually exist as a pull. Instead, he assumed that space itself is inherently smooth and flat. But when massive celestial bodies, like our sun, just sit in the space, they cause it to curve inward. So it's the geometric deformation of this smooth space that gives rise to what we experience as apparent gravity. To really picture this, the author provides a vivid, highly specific metaphor. The text says, it is like pressing hard on a girl's round and smooth face with an index finger. That pressure breaks the smoothness and forms an indentation, a dimple. That dimple is the curvature of space-time. But keep in mind, this really only works from a macro perspective. If you take a person, or just a small stone, their mass is far too small to deform space any noticeable amount. So at a smaller scale, there's practically zero apparent gravity. And, well, that brings us right to the other pant leg, the microworld. In stark contrast to the smooth, flat space of the macro world, the text describes microscopic space as not smooth at all. In fact, it is filled with countless flying, chaotic particles. It's practically boiling. These fundamental particles, which literally make up everything from massive celestial bodies down to a single grain of sand, have masses so incredibly close to zero that they are completely unable to curve space to produce gravity. Their trajectories just change completely unpredictably. When we map out the interactions in this tiny, chaotic realm, we run into a huge problem. The particles are moving, sure, but not because of gravity. Their motion is actually caused by three forces, which are created by exchanging other particles. So electromagnetism is converted from photons, the strong nuclear force comes from gluons, the weak nuclear force, bosons. But here is the absolutely critical takeaway. Literally none of these particle exchanges generate gravity. Therefore, quantum mechanics simply cannot explain gravity. Period. So the crucial point is this. The macro world and the micro world are obviously part of one unified, integral universe, right? But the theories we use to describe them, general relativity for the massive stuff and quantum mechanics for the tiny stuff, are completely incompatible. As the author bluntly notes, they cannot be mixed. They fundamentally contradict each other. We're left with a massive scientific crisis, one that requires a monumental bridge to connect them. Enter the waistband of our pants analogy. If general relativity and quantum mechanics are those two disconnected pant legs, the unifying mosaic trying to stitch them together is superstring theory. This is the grand, ambitious attempt to take these two entirely fractured theories and weave them into a single cohesive garment that can finally explain the overall face of the universe. Let's look at how superstring theory actually attempts this by zooming all the way down. The theory states that matter is made of molecules. Molecules are made of atoms, which consist of nuclei and electrons. Nuclei are made of protons and neutrons, which are made of quarks. Okay, for a long time, scientists thought quarks and electrons were fundamental point particles with absolutely zero internal structure. But superstring theory zooms in one step further, replacing those points with tiny, vibrating strings. And the core tenets of this theory, they are absolutely mind-bending. First, those fundamental point particles, they don't actually exist. Only energy strings moving in space exist. Second, the vast variety of particles we see are just these exact same basic strings vibrating in different modes or frequencies, kind of like different notes on a guitar string. But here is the kicker. The theory argues that our traditional ideas about space are completely wrong. These strings do not move in our normal three-dimensional space. No, they move in unimaginably high dimensions. The math actually requires 10 or even 26 dimensions. I know exactly what you're thinking. How can we possibly conceptualize a 26-dimensional universe? The author acknowledges right away that this is incredibly confusing and super difficult for anyone living in our standard 3D reality to grasp. So, to bridge this gap in our understanding, the author provides a brilliantly simple analogy. We are going to look at an ant and an elephant. Imagine an ant just crawling along on a flat, two-dimensional plane. On its journey, it falls into a shallow pit. It struggles, climbs out, and keeps walking. A few hours later, it falls into a deeper pit. It climbs out again. Later, it drops into a sand pit. And finally, after a bit more crawling, it lands right inside a mud pit. From the ant's perspective, just going about its day, these four pits, shallow, deep, sand, and mud, are completely random, totally disconnected, and entirely irrelevant to one another. And this brilliantly illustrates the aha moment of higher dimensions. From the 2D ant's view, it just sees four isolated, random pits. Because it's trapped in two dimensions, it cannot see any interrelation. But pan out to a higher dimensional reality, and we see an elephant was just standing there eating. One foot was on hard ground, one on soft ground, one in sand, and one in a puddle. What looked like isolated, random events in a lower dimension are actually distinct footprints left by one single, unified entity when viewed from a higher dimension. Now let's explicitly map this metaphor right back to our physics problem. The four pits that the poor ant falls into represent the four fundamental forces of our universe: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. Just like the ant, from our limited dimensional perspective, these forces seem completely disconnected, especially gravity. But superstring theory acts as the elephant. It suggests that if we just look from a higher dimensional perspective, these seemingly unrelated forces are actually integral parts of a single unified whole. Because of this massive potential, mainstream science holds incredible hope for superstring theory. It is widely seen as the most promising way to unify fundamental particles and interactions. For the first time, it merges general relativity and quantum mechanics into a mathematically self-consistent framework. Physicists genuinely believe it has the potential to fundamentally change our understanding of space and time, potentially solving massive mysteries, like the nature of black holes and even the very origin of the universe itself. Now, the prospect is definitely tempting, and theoreticians are struggling with it every single day. But right here, the source text executes a very sharp pivot. Despite all the mainstream excitement, the author, Xu Feng, offers a starkly different view. The text literally states, "But in my eyes, superstring theory remains ridiculous and childish because it has blind spots." This introduces a profound philosophical critique of mainstream theoretical physics. So, what exactly are these blind spots? Well, the author poses three critical questions that he argues physics has completely failed to answer. First, how have these fundamental strings actually come into being? Second, what exactly causes them to begin moving or vibrating in the first place? And third, could these strings truly represent the ultimate origin of the entire universe? The text argues that physics is jumping way ahead without answering the most foundational questions first. This leads us directly to the author's final conclusion. Xu Feng argues that it is logically impossible to establish a true unified field theory of the universe while the actual origin of the universe remains entirely unknown to science. The text boldly asserts that physics cannot answer these foundational questions and concludes that only Lifechanyuan, which is the author's own philosophical and spiritual framework, holds the ultimate answers to the origin of the universe. And that leaves us with a truly fascinating tension between the macro, the micro, the mathematical, and the philosophical. We've seen how the source text breaks down the gap between Einstein's smooth space and the boiling quantum realm, using that incredibly elegant metaphor of an ant and an elephant to explain string theory's higher dimensions. But it also leaves us with a profound challenge to mainstream science. Will the ultimate unified theory of our universe ultimately be found in complex, 26-dimensional mathematics? Or does the true origin lie in something beyond physics entirely? It's a question that, for sure, leaves you wanting to explore further.